Good morning, students. Welcome back to science class. Today we shall start new chapter, that is the sources of energy. Okay, you know, in ninth standard you had studied about energy and its forms. Okay, so in that chapter you had studied law of conservation of energy and why we need energy, what is the importance of energy, and how we calculate energy. Everything we had studied in ninth standard. Okay, and that chapter name is work and energy and its forms. Okay, so in this chapter, we shall discuss what is the importance of energy. Okay, how to convert one form to another form. See, in ancient just we had studied what we can convert one form of energy to another form, but this year we can clearly we can study how we can convert one form to another form and why we need energy. What is the use of the energies? Okay. Yes. Before that, I'd like to ask. The law of conservation of energy. Okay, I hope you know what is that law of conservation of energy. So here it states that energy can neither be created nor be destroyed, but we can transform one form of energy into other forms. Okay, so before converting and after converting, energy remains same. So this is the law of conservation of energy. Okay, for example, take one bulb. Okay, take one bulb. Okay, so it will blink when you pass electrical energy. So here we can say that this bulb, which is this bulb, it will convert what electrical energy into light energy and heat energy. Okay, so here this what is the function of this bulb? It converts electrical energy into light energy and heat energy. Okay, so here we will get one light energy plus if you use for long time when you touch this bulb, you can feel heat. Okay, so that's why here this bulb which converts electrical energy into light energy and heat energy. Okay, for example, if you take a candle. Okay, so candle which converts chemical energy into light energy and heat energy. Okay, so here the before conversion and after conversion, the energy remains same. For example, take one object. So this is the surface of the earth, the raised object, the raised here. So at this position, it possesses potential energy. It possesses potential energy. When you release that object, what will happen? This potential energy is slowly converting into kinetic energy. Kinetic energy. So here also energy can neither be created nor destroyed, but we can convert one form to another form. Here also the energy is just converting potential energy into kinetic energy. Okay. Things that we had studied in the ninth standard. Next. So here clearly we can say that before conversion and after conversion, energy remains same. For example, if you take one candle, okay, so that candle converts chemical energy into light energy plus heat energy. Okay, so here also before conversion, so that chemical energy is equal to the light energy plus heat energy. Okay, so here energy remains same, but that it goes into other forms. Okay, then if you take fan, okay, so that fan which converts electrical energy into mechanical energy. Then for example, take hydro energy, that water flow at the dams. Okay, so there we can generate electricity, right? So there hydro energy is converting into electrical energy. So here we can convert one form of energy into other forms. Next move to see sources of energy. So what are the sources of energy? For example, hydro energy, thermal energy, ocean thermal energy, tidal energy, wave energy, solar energy, then wind energy, nuclear energy, okay, chemical energy. These are the sources of energy. Okay, why we need energy? Day by day the population is keep on increasing, right? Keep on increasing, so we have to provide energy for everyone. Okay, so right now we are, see, earlier we are generating we were generated that electricity using water. Okay, see, using hydro energy, we can generate electricity. See, only we can't give that electric energy to everyone just by using hydro energy, because it is not sufficient. Okay, why? Because see, our daily works is just depends on electricity, right? Okay, because we are the importance of electricity, we are studying the electricity chapter. Okay, see, to provide for energy for everyone, so we need more energy. Okay, so we do not get more energy from hydro energy only. Okay, so that's why we have to use other alternative energy sources. Okay, so next, so what is a good source of energy? First question. What is a, see, we'll get energy from hydro, thermal, ocean, tidal wave, etc. But first, what is a good source of energy? When do you, how do you say that? See, for example, you have energy. How do you decide? This is a good source of energy. Okay. For that, we have to ask some questions. So before that, to run a vehicles, we use fuels. Okay. To for cooking purpose also we use fuel and natural gas. Okay, so now how do you say which one is a good? For example, you have petrol, diesel, and natural gas. Okay, so now my question is, out of these three, so I would like to ask, out of these three, which one is a good source of energy? How do you decide good source of energy? Okay, see here, for that we have to ask three questions. Okay, you have to think about three questions. So first one is, how much heat does it release on burning? First one, how much heat is how much heat is released? How much heat does it release? Okay, how much heat does it release on burning? Second question. Second one, does it produce a lot of smoke? Does it produce a lot of smoke? Does it produce a lot of smoke? Then third one, is it easily available? Third one, is it easily available? Okay. See here, first one, how much heat does it release on burning? Okay, that is the first point. Second one, does it produce a lot of smoke? If it produces a lot of smoke, so it is a dangerous, right? It is dangerous because it causes a pollution. Okay. Next, the third one, is it easily available? Is it easily available? See, these if you want these three, it is very difficult because we have to extract it from other sources, right? From more, the process of taking a petrol, diesel, natural gas, it is very, very difficult. Okay, so using some advanced technology, we can get petrol, diesel, natural gases. So that is second. Now, if anyone of if anyone any fuel it satisfies these three questions, these 3 points, so then we can decide it is a good fuel. Okay, so if it produces more heat and if it produces less smoke and if it is easily available, then we can say that it is a good fuel. Okay, see here, for cooking purpose we can see, for cooking just we need heat, right? We need heat, so we can produce heat using petrol, using diesel and natural gas. Okay, but we use only natural gas. Why? Because these two produces a lot of smoke, right? Correct, so that's why we can't use this. We can, but it produces a lot of smoke. Correct, so that's why we can use natural gas. Clear? And the third one, out of these two, petrol, if to run a vehicles we use petrol and diesel. We are using both. For some vehicles we use the petrol and for some vehicles diesel. Okay, so out of these two, to decide which is a good fuel. Okay, so we have to ask these three questions. We have to think about these three questions. If it produces lot of heat, and if it is produces less smoke, and if it is easily available, so then we can say that that is a good fuel. Okay. Next move to what is a good source of energy. Okay, how do you decide, or how do you say this is a good source of energy? For example, see, we have hydro energy, thermal energy, wind energy, solar energy, tidal energy, nuclear energy, chemical energy. We have a lot of energies, but how do you say this is good and this is bad? Okay, so here also, if you want to say you have an energy, this is a good source of energy, you have to think about some of these points. First I will write. So first one, see, first one, which could do a large amount of work, which could do a large amount of work. Large amount of work, okay, we should do a large amount of work per unit volume or mass, per unit volume or mass. Then second one, be easily accessible. Then third one, be easy to transport and easy to store. Easy to transport and store. Then fourth one, the important one, be economical. Be economical. For example, here, if you want to say good source of energy, first one, which would do a large amount of work per unit volume or mass. So here you have an energy source. See, we need more energy or more mass from. We need more energy and more work from that. That energy. Okay. Then second one, be easily accessible. It should be easily accessible. We should get that source very easily. Okay. Then third one, be easy to, for example, see here, thermal energy. So in the thermal energy we use coal. Okay, so using coal we will burn that coal and we will get heat from that. Then later we will convert that heat into electrical energy. But here to get coal, that is, it is little bit difficult. Okay, because there is some processes there. So it is not easily accessible. So compared to hydro energy means what? Just it is a flow of water. Okay, water is falling from the high places, from high position. Okay, so out of that hydro energy and nuclear energy, hydro energy and thermal energy, so which one is easily accessible? So hydro energy is easily accessible. Okay, next, be easy to transport and store. Be easy to transport and store. Okay, then it should be economical. So this is very, very important, because it should be, if it is very costly, then we can't use. Okay, so only rich people can use that energy. What about poor people? So that's why it should be economical. Okay, first one, it should do a large amount of work. It should do a large amount of work in a less mass. Okay, less mass. For example, you have some energy, it should do a lot of work. Then it should be easily accessible and easy to transport and store. Okay, next, and it should be economical. If any source satisfies these conditions, then we can say that, so that is a good source of energy. So clear of good source, what is the source of energy? So if any energy satisfies these conditions or these points, so then we can say that that is a good source of energy. Okay, yes. Next, see next motto, conventional sources of energy. Okay, first one, fossil fuels. Yes, sir. Next motto, fossil fuels. See, fossil fuels means coal, natural gas, and petroleum products. So these are the fossil fuels. See, already I have told what. So using hydro energy, we can generate electricity. Okay, so we can generate electric energy. So we can't supply that electric energy to everyone. Why? Because day by day the population is just keep on increasing, right? Because the water is not available in every time. Water is not available every time. So using the hydro energy, we can't send or we can't give energy to everyone. So for that we have to use other sources of energy. Okay. So first we will discuss fossil fuels. So fossil fuels means one which includes coal, natural gas, and petroleum products. Okay, petroleum means natural gas and petroleum oil. So petroleum oil, which in petroleum products, which includes diesel, petrol, everything. Okay. So first, you know how these fossil fuels are made. You know, million years ago, the microscopic parts of the plants and the animals, everything buried under the ground. Okay, so due to the high pressure, what due to some chemical reaction, okay, took place. So due to that, these fossil fuels are formed. Okay, see these fossil fuel to form once again, it requires millions of years. What is that? Millions of years. See, right today we are using coal. That coal is formed over million years ago. Okay, see if we lost those fuels, then it once again to refund to it will take more than millions of years to form once again. Okay, so that's why these fossil fuels are a limited period. So first one. Now we'll discuss using coal. Okay, how we can generate electricity. See, before that, take one simple example. You know, cooker, rice cooker. Okay, just when this is a cooker, and here whistle. Okay, so just here you have to connect one pipe. You know, while boiling, you will get a steam, right? You will get a steam. Steam means what? That is air. The air will come with high pressure through this vessel. Okay, so now you have to connect one pipe like this. To connect one pipe like this. And here you have to keep one fan, mini fan. Okay, one fan, and you should connect this fan to a small dynamo. Okay, and then we should connect this dynamo to one small bulb. Small bulb. You know, here while boiling, what happens? The air, the steam, it will come with high pressure, right? So it will pass us through this pipe and see here. So due to the that steam, it passes through this pipe, right? So here this fan, it will rotate. Okay, so while rotating, what actually this fan is connected to dynamo. So we'll discuss in the magnetic effects of electric current chapter how this dynamo converts into how we can get electric energy from dynamo. So here while rotating this fan, why this fan is rotating? Because here through this pipe hot steam is coming out. Okay, so this fan it will rotate. So this fan is connected to dynamo. This fan is connected to dynamo. Okay, so this dynamo, this fan it rotates this blade. Okay, what we will discuss in detail in magnetic effects of electric current chapter. Okay, so later, so here one bulb is connected to one this dynamo. So this dynamo which converts what mechanical energy into light energy. So now here we can get electricity. Just here we have used cooker, fan and dynamo. Okay, the same process takes place in thermal power plant. Okay, so in a thermal power plant we use coal. Okay, so we use coal to produce heat. Okay, so I think we have seen this kind of in near thermal power plant. Okay, see here. And here, see in thermal power plant, there are some sections of that. First one is coal section. There they will store coal. Okay, then and these are boilers. Okay, boilers here we will boil we will burn that coal. Okay, then so here we will burn that coal, right? Here we will connect. Okay, here we will. See here while burning, we use coal. Okay, so to burn we use coal. Here lot of steam is produced. Okay, then we will pass that steam to one turbine. Turbine means just like a fan. Okay, just like one wheel. Okay, so we will pass. See that we will pass that steam because that steam is in high pressure. Okay, it is a huge amount. It gains huge amount of velocity. Okay, so that steam is passed to turbine. Then that turbine is connected to what one dynamo or electric generator. Okay, that dynamo is connected to generator. Now this generator means we generates electricity. Okay, in the generator here we use some magnets. Okay, and some coils. So here this turbine is connected to generator. We'll discuss in the magnetic chapter. Okay, how it generates electricity. Then this generator is connected to transformer. Okay, see here. First in the thermal power plant, first we pass that coal to what to boiler. So there we will burn that coil. That we will burn that coal. Okay, so due to burning of that coal, huge amount of steam is produced. So then that steam is passes to turbine. So then that turbine starts to rotate. Then that turbine is connected to generator. Okay, so then this generator is connected to transformer. So here this generator, here we have used one what we call a rotor. Okay, so we keep this between magnets. So here this turbine is connected to generator, right? It starts to rotate. So due to the rotation, what happens? This generator which generates electricity. Then we will pass to transformer. Here, see here we are using transformer just to increase the voltage. Because the voltage from the generator is little bit less because we need a huge amount of velocity, huge amount of electricity, huge amount of voltage. Okay, so that's why to increase that voltage we use transformer, so that it is we pass to main lines. Okay, so later we can pass to other areas. Okay, for homes, etc. So here first in thermal power plant, first we burn the coal and steam is produced. That steam is passed to turbine. Okay, that turbine is connected to generator. So which turbine, when you pass that steam, okay, then that turbine starts to rotate. Then the generator is connected to transformer. So here we can generate electricity. Here first here heat energy. What is that? Heat energy is converting into mechanical energy. Then mechanical energy is converted into electrical energy. Okay, so first heat energy. Heat energy is converted into mechanical energy, then mechanical energy is converted into electrical energy. So here we have converted, right, one form of energy into other forms. First heat energy into mechanical, mechanical into electrical energy. Okay, so here also, and so here also, here and here, the before conversion, after conversion, energy remains same. And here we use some coolers just to cool the pipes, because huge amount of heat is produced, right? Okay, and to reduce that heat, we use some cooling system. Cooling system means we provide water. Okay, so this is the working of thermal power plant. Here just we convert heat energy into mechanical energy, mechanical energy into electrical energy. Yes, sir. So now we will discuss what are the advantages. Okay, what are the advantages of thermal power plant? Here, advantage we can say first one is it is economical. Economical because it is very cheap. Okay, here it is not highly expensive. Then see, if you plant, see, if you construct, if you install once, that is enough. No need to install again and again. Okay, and actually, see, we will install these power plants where we will get the coal at the coal fields only. Coal field means there we will get the coal, and there only we will install these plants. Okay, so here it is economical, and see, and it is not too much expensive, but it is not too much expensive comparing to other sources of energy. Then what are the disadvantages? Okay, so disadvantage, lot of smoke is produced, right? So it requires a huge amount of area. Okay, so these are the disadvantages. Yes, next move to hydro energy. Next move to hydro energy. Okay, see, hydro means what? It's liquid, that is water. So here, due to the water flow, so using that water flow, we can generate electricity. Just imagine the water is falling from high place. Okay, just imagine water falling from a high place. Okay, so that water it will fall with a huge amount of force, right? While falling downwards, so it will fall down with a huge amount of force. Here, if you keep one fan, what will happen? It starts to rotate. So instead of that fan, just keep one turbine. Just to keep one turbine. So then this turbine we will connect this turbine to generator. Okay. See, in thermal power plant we use steam. Why we use that steam? Just to rotate the turbine. Okay. So instead of that steam, here we are using water motion. Okay, that is water flow. Using that water flow, here we will rotate that turbine, and this turbine is connected to electric generator. And once again, say this generator is connected to transformer. Okay, see, there in thermal power plant, in thermal energy, we have used steam just to rotate the turbine. Instead of that steam, here we are using water flow. Okay, so using this water flow, we are rotating this turbine. Clear? So from this we can generate electricity. See, sometimes the high position of these. See here, this water will fall from the hills somewhere. Okay, so sometimes we use some dams. So from using dam also we can generate electricity. Okay, dams, right? There are so many gates in the dams. Okay, so when you release the gate, what will happen? That water, it will come with a huge amount of force. Okay, while moving in that motion, in that path of that water, if you keep turbine, what will happen? So once again, this water, it rotates the turbine, right? So once again, same, this turbine is connected to generator and to transformer. Okay, so here we are using that water motion or water flow just to generate electricity. So here first we'll convert hydro energy into mechanical energy, then mechanical energy into electrical energy. Okay, hydro energy into mechanical energy into electrical energy. Next, so here what are the advantages? See, advantages means here the fuel is water, right? The fuel is water only. There the fuel is coal. And one more thing, the disadvantage of thermal power, the coal is only, it is available for limited periods. Okay, see, if you use at the rate of huge amount, at the rate of very high, at that time you can't use the coal for many years. Okay, if you use for continuously, so soon will run out of that one. Okay, so this coal is only, it is available for limited periods. Next, and water, here water, right? So water is the fuel. Next, other advantage. Sorry, next, what is the advantage? So here also, if you construct once, so no need to construct again and again. Okay, and it is a cheap source of energy. Okay, first one here fuel is water only, and it is cheap source of energy. Next, the energy used is a flowing water, which is a renewable source of energy, and which is a renewable. And see, in energy there are two types. One is renewable source of energy, and another one is non-renewable sources of energy. Okay, see, first we'll see what is the renewable sources of energy. See, a source of energy which can be renewed again and again. For example, if you take water, you will get water again and again, right? Clear? Next, suppose if you take a coal, you won't get that coal again and again. If you lose that coal once, then to reform it takes millions of years. Okay, so what is renewable energy? Renewable energy means a source of energy which can be renewed again and again with a relatively short period of time is called renewable source of energy. We can name the renewable source of energy. First one is solar energy. Okay, solar energy, wind energy, and energy associated with the flowing water, energy associated with the sea. Next, nuclear energy, geothermal energy, tidal energy. Okay, these all are renewable sources of energy because we can renew these energies again and again. Clear? So what is a renewable source of energy? A source of energy which can be renewed again and again with a relatively short period of time is called a renewable source of energy. So what are the examples for renewable source of energy? Wind energy, solar energy, then energy associated with the flowing water, and the energy of ocean waves, tidal energy, nuclear energy, geothermal energy. And next, what are non-renewable source of energy? Okay, so non-renewable sources of energy means the sources of energy which cannot be renewed again and again, So those energies are called non-renewable sources of energy. For example, natural gas, petroleum oil, and coal. Okay, natural gas, petroleum oil, and coal. So these are examples for non-renewable sources of energy. Okay, next. So clear, right? So renewable source of energy and non-renewable. So we were discussing advantages of hydro energy. First one, it is here the fuel is water, so that's why we can say it is very cheap, and it is a renewable source of energy. But thermal power plant, it is non-renewable, or it is non-renewable source of energy. Okay. Next, what are the disadvantages? And one more thing, see here we are constructing. If you construct a dams, what will happen? Which controls the flood also, which controls the floods. Okay, so this is also a advantage of hydro energy. Okay, and one more, it does not produce a lot of smoke, lot of heat and hazardous gases. Okay, and radioactive some radiations, harmful radiations. Okay, so the first advantage is it is here the fuel is water, so that's why it is very cheap. Second one, which controls the flood, and third one, it is a renewable source of energy, and fourth one, it does not produce smoke and harmful radiations, etc. Because here there is no pollution, right? But in thermal power plant there is a pollution is there, because lot of amount of smoke is produced. Okay, but here there is no smoke. And what are the disadvantages? See, this hydro plant can be established only in a selective places where an appropriate amount of flowing water is present. We can't construct that dams everywhere. Okay, and water is not available in the whole year. Clear? So these were the disadvantages of hydro energy. Next, dams. See here, to construct dams, what will happen? It requires more space. Okay, so what will happen? Which kills the ecosystem, right? Because everything is submerged under the dam. Okay, so which kills the ecosystem, and yes, it requires more area. So these are the disadvantages of hydro energy. Yes. So now I will stop here. Tomorrow I will continue the class. Thank you.